now we're going to do question 3, and the above statement reads as follows. A boy standing on a bridge projects a ball, which is ball A, vertically upwards with an initial velocity of 5 meters per second. The height of the bridge is 20 meters. Ignore air resistance. So 3.1 says that give the magnitude and direction of the acceleration of ball A as it leaves the boy's hand, right? So we're having this ball and it's projected vertically upwards, right? Obviously the motion is going to move like this. So now the only force that is acting on this ball as it moves upwards is the gravitational force, right? So meaning that our acceleration for this question is going to be 9.8 meters per second squared. Now going to 3.2, it says that calculate the total time it will take for ball A to reach the road. So what we have here is this scenario where we have this bridge. Let's say the bridge is connected from this point A to point B, and then this person here is going to throw ball A vertically upwards, and it'll go down like this. So this is the height, which I'm going to indicate it's y1, and then just below the bridge is the road. So this would be the road, and this is the final point of ball A. So what we are most interested in is the time it took for the ball to reach ball A, right? T of A. So for us to do that, we know the initial velocity is equal to 5 meters per second, and the final velocity here at the top is equal to 0 meters per second. And we know that the velocity at this point is also v equals to, let me just say velocity and not say initial because it can change. So let me say v is equals to 5 meters per second, right? And now what we know is that the height from this point up until this point is 20 meters, right? We were told that the height is 20 meters. So now we are going to find the time of ball A at the road, right? So for us to find this, we first need to identify the time it will take the ball to reach this maximum height, right? So if the time it will take for the ball to reach this point here, and then after that we'll go straight to the bottom of the road, or the road rather, right? So I'm just going to indicate with the diagram. So the initial is from this point going to the top part, right? So I'm just going to find the time it took for the ball to reach the height, the maximum height. T is equals to, so we know the v initial is equals to 5 meters per second, and the v final is equals to 0 meters per second. So we're going to use the equation v final is equals to v initial plus g multiplied by t, where the v final is 0 but the v initial is 5, plus our gravity is going downwards, so we will take down as negative, so it's going to be minus 9.8 multiplied by t, right? We want to transpose the 5 to the other side. We have minus 5 is equals to minus 9.8 t. Then we divide by minus 9.8 both sides, and our t is going to be 0.510 seconds. So this is the time that it will take the ball to reach that maximum height. So t is going to be 0.510 seconds, right? So now we are going to identify the time it will take the ball from this maximum height all the way up to the road, right? So how we can find that is, let me do this. So just gonna read through the diagram. So it's from the maximum height where v initial is equal to 0 meters per second. If I consider it as v initial, and at this point it's the v where it's equal to 5 meters per second, so it's still at the top of the bridge. And then there is our y1, and then we go straight to the bottom where there's the road. So now we're interested in the time it will take from the maximum height all the way to the road. T is equals to. So what we will do is this. We are going to first find the height, because we already know excuse me, we already know the height or from this point. We know the height from this point is given as 20 meters, right? We were told that it is 20 meters, but we don't know this y, right? So we can find that y where we can say v initial is equal to 0 meters per second, v final is equal to 5 meters per second. So by finding this y, I want us to use the total height all the way from the top to the bottom to find time, right? I'm just going to indicate it as y3. So let's first find this y1 here. So it's going to be v final is equal to v initial squared both sides plus 2 multiplied by g multiplied by change in y. So the v final is going to be 5 squared is equal to v initial is 0 plus 2 multiplied by your 9.8 and then change in y, right? So if you divide, because you're gonna have 5 squared is equals to 2 times 9.8 times change in y, and then you divide both sides by 2 times 9.8 divided by 2 times 9.8. So your change in y is going to give you 1.276 meters. So that is your y1. y1 is equals to 1.276 meters, right? So now that we found our y1, so meaning that the total height from the top where our velocity is 0 all the way to the road would be the total height is equals to y1 plus 20 meters, which is 1.276 plus 20 meters, giving us 21.276 meters. So that is our total height, right? So we'll use the total height to find time. So you can simply say y is equals to v initial multiplied by t plus 1 over 2 multiplied by g t squared. Our initial velocity, remember that our initial velocity is 0 meters per second. If we are saying we're starting from this top point, right? The reason why we're starting from this top point is because we are using maximum height and we're going all the way down, right? So our initial velocity is 0 meters per second. So making this portion here being equals to 0, right? So we're going to have y is equals to 1 over 2 gt squared, right? So because we have our y, our maximum height, which is 21.276, so we're going to write it 21.276 equals to 1 over 2 multiplied by 9.8 meters per second. So we're just going to write t squared there, and then you're gonna cross multiply. So you're just gonna cross multiply. Here it's gonna be 21.276 multiplied by 2 divided by 9.8 is equal to t squared. So you're gonna put the square root both sides, and then your t is going to be equals to 2.0837 seconds. So this is going to be your time from the maximum height all the way to the road. So hence we're going to write it here, which is going to be 2.0837 seconds, right? So now, because our ball moved from the starting point going all the way up to the point of maximum, going all the way down and straight down to the road. If this is the road and if this is the bridge, the time, just going to indicate the time. The initial time that we found here is equals to 0.510. Now, and then the time it took from this point of maximum all the way down to this point, it's t is equals to 2.0837 seconds, right? Now we're just going to add these two times because this is the initial point, right? So you need to calculate the time from the initial point all the way down to the road, right? So you're going to add this time here and this time here to get the total time. T total is equals to 0.510 plus 2.0837. Then we're going to get 2.59 seconds. So now the statement says that at the same time that ball A is thrown upwards from the top of the bridge, another ball B is projected up from the road. Ball B has an initial velocity of 14 meters per second. 3.3 says that we should calculate how far apart ball A and ball B after 1.2 seconds. So what's going to happen is this. This ball A is going to move like this, and we don't know which point it's going to reach, but what we know is it's going to reach maximum height here, and then it will go down. But if you remember clearly that the time it took for it to reach maximum height from this point here on the bridge was equals to 0.51 seconds. This is from the previous question, right? So that neglecting air resistance, we can assume that the same amount of time will be experienced, t being equals to 0.51 seconds, right, from this point up to this point, right, where here the velocity is also 5 meters per second, right? So now the whole point is of me doing this, and this is to just give you the time, the total time. 0.51 plus 0.51 is equals to 1.02 seconds, right? So this means now that it took the ball 1.02 seconds to reach this point here, right, of the bridge. So the reason why I'm showing you is that we are told to calculate how far ball A and B are between each other after 1.2 seconds. So this tells me that 1.2 seconds will be after this point. It will be here, probably somewhere here. Ball A will probably reach, just to write it nicely, 1.2 seconds might be somewhere here. So if it continues to move, and maybe let's say this is the point, let's assume 1.2 seconds will be this point, because from this point it's actually t being equals to 1.02 seconds, right? So here, let's assume t is equals to 1.2 seconds, right, for ball A, right? So now, what's going to happen is this, ball B, which is this one here, will move. Let's say this is ball B. It moves vertically upwards. Let's say it reaches this point, and this point is where t is equals to 1.2 seconds, right? So what you are seeing here is ball A and ball B facing each other as they are projected, right? So we are more interested in this height here, the difference in the height between ball A and ball B, right? So for us to be able to calculate that height, we will use the total height, and then we'll subtract it with this height here, because we should calculate this height, let's say y of A, and we'll calculate this height here, which is y of B, and then we subtract both heights from the 20, which is the height of the bridge, and then we'll be able to get this height here, which, let me just indicate height between A and B, right? So the whole point now is to calculate this height of A, and secondly calculate the height of B, and then we'll continue the rest. So for us to do that is, let me just write here ball A, right? So for me to calculate the y of A, we're going to use the equation of y is equals to v initial multiplied by t plus 1 over 2 gt squared, right? For y of A, right, this one here. So to find this y of A, we know that our initial velocity is 5 meters per second if we consider from this point of the bridge, right? So it's going to be equals to 5, and then the time it takes for it to reach this point is equals to 1.2, right? It's going to write 1.2 there, and then plus 1 over 2 into the gravity is going downwards, right? So it's just going to be negative. So this will be negative 9.8, and time is 1.2 squared. And the y that you're going to get if you punch your calculator is going to be so you're gonna get minus 1.056 meters. So the minus just tells you that the object is moving downwards, right? So this is just the direction of the height of this ball, right? So we now found y of A, right? So we already found y of A, this one here, which is equals to minus 1.056 meters. So now we want to find y of B, right? So to find y of B, we're gonna say ball B, y of B. So we're going to use the same equation. So it's y is equals to v initial multiplied by t plus 1 over 2 gt squared. And we'll substitute the initial velocity, which is this one here, 14 meters per second. And then the time is 1.2 plus 1 over 2 multiplied by g. We know g is going downwards, so it's 9.8, and 1.2 there squared. So the y that you are supposed to get for this y of b is equals to 9.74 meters. So it means now that it will reach 9.74 meters. So we're just going to write it next to it, so it's equals to 9.74 meters. So now that we found y of A and y of B, we can easily find y of AB, which y of AB stands for the difference in height between the two balls, right? So for us to find that, we will say y of AB, which is the difference, is going to be 20 meters, which is the total height of the bridge, minus y of A minus y of B equals to, so it's 20 meters minus our y of A is going to be 1.056. I know we wrote it as negative here, but once you substitute it here, you substitute it as positive because the negative stands for the direction of the height. And then we're going to minus the y of B, which is equals to 9.74. So if you subtract minus 1.056 minus 9.74 from 20, you're gonna get y of AB being equals to 9.2 meters. So this is the height that ball A and B are apart from each other. So that means now this this point here, y of, so this means now that this y of AB is actually 9.2 meters. So now the tennis ball A hits the road below, stays in contact with the road for 0.2 seconds before it bounces up at a velocity of 14 meters per second. So in 3.4, we are asked to draw a velocity versus time graph for the motion of ball A from the time it was projected up from the bridge until the time it rebounds to a maximum height. Clearly indicate the following on your graph: the initial velocity of the ball, the time when the ball hits the road and it is in contact with the road, the velocity of the ball when it rebounds from the road. So remember the motion of the ball A. If we say this is the bridge and this is the road, then ball A's motion started from this point going upwards all the way to this point going downwards up to this point. So what we are told is that it became in contact with this road, the surface of this road, and then it bounced upwards, right? So we don't know up to what height, but we know that it bounced. So when it started bouncing and going up, the velocity started being equals to 14 meters per second, right? So we're most interested in finding out the final velocity, right? So I just want us to find the final velocity after it was in contact with the surface, right? So what we're going to do is this: we're going to say we're going to take the time. So we know that it was in contact with the surface for 0.2 seconds, right? And another thing is the initial velocity. The v initial here was equals to 5, meaning here it is also v equals to 5 meters per second, right? And we know the height of the bridge being equals to 20 meters, right? So the first thing we can find now is the final velocity as it reached the ground. What is the final velocity, right, as it moved from the initial velocity of 5 meters per second going downwards? So what you want to do is you want to say v final squared is equals to v initial squared plus 2 multiplied by g multiplied by change in y. So we want the v final, so the initial is 5, so it's going to be 5 squared plus 2 into g, it's minus 9.8, and our change in y, if we just consider the height from this point going to this point because the initial velocity is 5, right? So we're just going to start at that point. So we're just going to say 20, which is negative because of the direction. And then you can just square everything up because we want v final squared, right? So it's going to square everything up, and we're going to find v final being equals to 20.42 meters per second. So this is the final velocity as the ball reached the floor of the road, right? Or the surface of the road rather. So v final is equals to 20.42 meters per second. So now that we found the final velocity, then what we can do now is want to find out the velocity of the ball as after it bounces off the surface, right? Because what happens is, as if we consider this as the surface of the road and the ball bounces, when it bounced, its initial velocity was equal to 20.42, right? Because it was coming from the top, and then it bounced, and then immediately after bouncing, the velocity here initial is equals to 14 meters per second, right? So we want to find the velocity here, v final velocity, right? The reason why I want us to find the v final is because of this last statement in 3.4.3, where it says we must indicate the velocity of the ball when it rebounds from the road, right? So what we're gonna do here is this: we're gonna say because we found this v final here being equals to 20, right? So we're gonna say v final is equals to v initial plus gt, right? So the v initial, we're gonna consider this being v initial, so it's going to be 20.42, exactly as I wrote here, plus our gravity being equals to minus 9.8, and the time is the 0.2 that it's spent with the surface, so it's the contact time. And the velocity that you're gonna find here, it's 18.46 meters per second. So this is the final velocity of the ball, right? So if we draw the velocity versus time graph of this situation here, is gonna look like this. So this would be our Cartesian plane, looking like that, and then this, from this point here, this is our initial velocity where it was 5 meters per second. So v for velocity, t for time. So the object started at initial velocity of 5 meters per second. It went up until it reached maximum height, which was 0 meters per second. Then it went down, reaching the same velocity of 5 meters per second. Then it went down, further down, up to the final velocity, which I calculated, v final being equals to 20.42 meters per second, which is this one that I calculated. So this would be your first line of sketch. So these are the points, and then it became in contact with the surface, right? So the contact time was 0.2. So let me just indicate here. So this is the contact time, 0.2 seconds with the surface of the road. Then it started moving. So now the velocity of this object here, we're just gonna consider it as 18.46 18.46 is the velocity. Then it moves upwards up until it will reach maximum height where the final velocity will be 0. So this would be our second sketch of this problem here. So yeah, this would be your velocity versus time graph.